Yeah, at NECN we have something we call weather on the ones, and basically what that means is every time that minute hand hits one past the hour, 11 past the hour, and so forth, we're doing a weather segment. So it comes out to a number of live hits, that we do over the course of the day. Most of our programming on NECN is live now. So on a busy storm day, for example, you're doing at least 78 live weather hits over the course of the day. It's a lot.
And you do most of them, too.
I do. Yeah, that's just on my shift. Then we have a whole nother shift that does even more in the evenings.
Could you go into a little more in-depth as to how you put a weathercast together?
You know, it's a great question. A lot of people ask, how do you make a forecast? How do you come up with that? And the bottom line, Larry, is that there's a lot that goes into it that ranges from experience, being able to recognize weather patterns, kind of paying attention to the world around you. Sometimes, believe it or not, sometimes the old tried and true methods are the ones that work the best. Looking to the sky, what kind of clouds are building up there? Which way is the wind going? How has it been shifting? Things like that. What's the barometer doing? Is it rising? Is it falling? So the old tried and true methods that have worked for hundreds of years still work pretty darn good. At the same time, of course, technology has come a long way. I mean, computers are a big part of meteorology, and I think a lot of times, it's easy to think, oh, well, the computers must just tell you what's going on,
Yeah, right.
Not the case. I mean, we have hundreds of different versions of them, and most of the time, no one guidance product is going to be right on the money. So that's where you kind of take everything into consideration. That's where you take both your experience into account, you take your observations into account, and you take the technology into account as well.
Now, we've had a lot of severe weather, and I don't
Yes,
just
we
mean
have.
this region. I
Right.
mean nationally as well
Yes.
as worldwide. Do you have any thoughts on that?
Here's the deal. When you
Is
look
it the
back,
end of the world?
It's not the end of the world. I can promise you that.
Okay,
It is not the end of the world. It's not apocalyptic. It can be concerning because not only do we have these events going on, but of course we have a media that's reporting things like never before. So we're seeing more of what's going on around the world. We're getting more details and more video of what's going on around the world. In addition to that, though, when you go back in time, we've had periods of time that last a few decades that bring very active, very extreme weather, both to the United States and across the world. So this isn't the first time we've seen this. There's been a long and extensive drought in the western United States. A lot of folks say this is one of the worst droughts we've seen. Well, yes, back in the 30s, of course, the Great Dust Bowl was another big drought then. We've had a lot of strong hurricanes. Katrina will always be remembered for the tremendous damage that she caused. At the same time, although she did reach record strength out over the Atlantic Ocean, when she struck, she was actually a Category 3 storm. Andrew was far stronger than Katrina by magnitudes. And when you look back in time, you can go back to the 1930s, you can go back to the 1800s, and you had storms that were stronger than Katrina. What we've done, though, and this is a really important thing to remember, is we have people living in so many more areas now. So many more areas of California where the wildfires used to burn, now there are homes there. Along the coastline where the hurricanes used to hit, now there are multi-million-dollar estates there.
Right.
And so that means that your damage potential has gone up significantly.
Now, talking about severe weather, could you give an indication as to what the ingredients are of some of these severe weather conditions?
Sure. It all goes back to kind of the basic thing that we all learn in school, which is when hot and cold comes together, that's not a good thing. And basically what we've been looking at, for example, over the course of the past really several years, is we're looking at building heat out of the tropics because we're getting warmer and warmer oceans, we're getting warmer and warmer air, and that is clashing with cool air that just doesn't want to let go out of Canada. How about the big tornado outbreaks that we've had so far this year?
Right.
Record numbers of tornadoes, record numbers, sadly, of injuries and fatalities. That's coming not just because of warmth from the south, but because of cold that just won't let go in Canada and the United States. It's that clash of warm and cold that gets storms going, and that's what really causes your problems. Here in the Northeast, same type of thing. Cold air has not wanted to let go out of Canada. The warm air, it's summertime, have been ready to come up, and so you get these clashes. That creates your storms. Winter storms, same deal. The oceans, the circulation a little bit warmer, the cold air still in place from Canada. There again, you get that clash that can cause the big storms.
What are the fundamentals of weather? What are the things that a weatherman looks at?
I wish I knew. I'd have it all figured out.
Well,
I've
you have some nice tools like the,
we
coin
do.
in your pocket.
Yeah, that's right, and the dart. Don't forget the dartboard,
That helps.
That's
works.
right, and I promise we do not have Larry Seaman on that
No,
dartboard, all
I
right?
hope not,
I promise. No, but seriously, the fundamentals of weather, I would say, really boil down to just kind of the simple things to some extent. It's like we were talking about with recognizing what kinds of weather tends to portend or foretell of what kinds of weather might be on the way. So what kind of clouds are coming in, things of that nature. Having said that, of course, with the technology, you hear about Doppler radar, and you hear a lot about that. It's become kind of a buzzword, almost a gimmick now. Doppler radar, you know, and check out our Doppler, it's bigger and better than yours. But really, you know, Doppler radar it's based on a theory that's been around a long time by a scientist named Christian Doppler, who basically recognized that when a car goes by beeping its horn, it doesn't sound just like beep, it sounds like beep, beep. It changes pitch because the sound waves get squished coming toward you and stretched going away. Radar works the same way. Send out radar beams. If the raindrop is coming toward you, it gets squished. Yeah. If the raindrop's going away, it gets stretched. What that means is we can see when air is spinning. We can see when raindrops are coming toward us or away from us. We can see things like tornadoes as they develop in the cloud. And that's why now there's an average of about a 22-minute warning on tornadoes before they touch down. Doesn't mean everyone gets a 22-minute warning, but it does mean that on average, that's the way it works out. So technology has come a long way, and certainly things like radar, things like fantastic satellite analysis, satellite imagery, a big part of weather. And then again, the computers, the calculations, math and physics, huge in the world of meteorology. Computers, the faster we get those supercomputers going, the more math and physics we can do, the farther out we can go, and the more calculations we can do.